All right, guys, some of you missed a day of class where we did an assignment called Projectile Motion. Basically, we did story problems using quadratic equations and launching, throwing, dropping things through space. So come to class, grab the notes, grab the worksheet, come back to the video, and you can give this a watch and you can take the notes before you do the assignment. So it's a pretty easy assignment. Most of the work is done on Desmos for you. You just have to know what you're looking for. So projectile motion is defined as a form of motion in which an object is thrown, or sometimes the object's just dropped. It's not like projectile through space, it's just dropped in space. The only force of significance on that object that we worry about at this level, the only thing acting on that object once it's thrown into the air is the force of gravity. So gravity is pretty cool because we have a simple equation that you can use when you're dealing with something going through the air and gravity pulling it back down to the earth, right? That equation looks like this. Y equals negative 16 t squared plus, this is called V naught. It's V with a little zero, V naught t plus H naught. Again, H with a little zero. Now, these different letters represent different things, okay? The Y value is the height of the object at some time. All right, and that's going to change. Most of you have been around long enough to know that you throw something in the air or launch something in the air, it doesn't stay at the same height. It goes up and then comes back down. So that value is going to change as time goes on. The t value, I make it a lowercase t. You can use uppercase if you want. But the t value represents time. How long the object has been in the air, all right? The negative 16, that represents gravity. That's the force of gravity, and it's pretty close to what the actual force is. If there's an object in the air, that's the strength of gravity pulling the object back down to the ground. Sometimes on some of the story problems today, they won't use negative 16, they'll use negative 5 or negative 4.9. Don't panic, it's the same problem. But other countries don't use feet and inches, they use meters. So if you're doing a question that's using something like meters, you're going to see negative 5 or negative 4.9 instead of negative 16, but it still represents the same thing. That is still gravity pulling the object to the earth. Now V naught, V with that little zero, that is called your initial velocity. And if you have a hard time understanding what velocity is, you could put speed next to it. So that's how fast the object is going at 0 seconds. Right at the beginning, right when the object is thrown or launched, how fast is that object going? Obviously, that number depends on the story problem. If this was a cannonball getting launched in the air, that would be a really high number because the cannonball is going to be going fast when it comes out of the cannon. If that number, if the story problem was somebody throwing a football, that number's not going to be nearly as big as if it was a cannonball because you can throw a football far, but it's not going to go as fast or as far as a cannon, right? So that number changes. For each story problem, it's different. And same with H naught. H naught is the initial height of the object. So maybe the object is getting thrown off of a roof, or maybe the object is getting launched out of an airplane that's flying through the air. Maybe the object is on the ground, it's a soccer ball, and it's going to get kicked into the air. So that H naught, again, it changes depending on the story problem. It's always a different number. It just represents how high the object is in the air. Now, all of these graphs look the same. You're not going to have to do these by hand. In fact, all of the problems today, it's going to give you the function. You don't have to come up with what number goes where. It's going to tell you what number goes where, and it's going to give you the equation. all you have to do is type that equation into Desmos. And Desmos is going to give you a picture. It's going to give you a graph of the object moving through space, right? So if I were to graph this scenario, one of these scenarios, basically what's happening is there's an object, it's going through space, and then it's coming back down, right? So my graph is going to look something like this. Now, a few people got confused because this parabola goes down forever. That doesn't mean your object is falling forever. In fact, this point right here represents when the object hits the ground. That would maybe be a good thing to write down. That point is where the object hits the ground, okay? If there was no ground, then the object would keep going, right? And that's why the parabola keeps going. But in the context of the story problem, even though the graph keeps going past the ground, the object might not, all right? If it's getting thrown over water, maybe it does go past zero. Maybe it goes underwater a little bit. Maybe it's a really heavy object and it goes into the ground a little bit. But in the story problem, that point right there represents when the object hits the ground. So don't get confused that it keeps going on the graph. It's not going to actually stop at that point. Which kind of brings us to another idea. Our axes on these graphs, the up and down is so nice because that represents height. So my y-axis represents the height of my object. My x-axis represents time. Okay, so it's kind of like these little tick marks going across here are seconds, and the tick marks going up the graph, these represent heights, like 5 feet and 25 feet. Whatever it is, that's what it represents, okay? So the nice thing about this graph is it looks like what's happening in space, right? The object is getting thrown and it goes higher and higher, and then it reaches this point right here, which maybe we should talk about. We call that a vertex. In the story problem, that vertex is the maximum height, right? That's the highest the object is going to go, and then the object's going to start falling back down to the ground. And I love this graph because that's what it looks like. My graph looks like an object going up in the air and then falling back down to the ground. The graph doesn't always look like what's happening in the real world. This one does, which makes it a lot easier to solve the problems, okay? So we know where our maximum height happens, and Desmos is great because when you type this into Desmos and you click on this graph, if I were to take my mouse and click somewhere on this graph, this dot shows up. So does this dot. So does a dot right here. All these different dots, that one right there, that's your starting height, by the way. All those different dots show up so that when you click on it, it gives you a X and a Y coordinate. So like if I were to click on one of those dots, it would give me an X value and a Y value, and the X value would tell me what's the time at that point. And the Y value tells me what's the height at that point. So if I clicked on this dot right here, my height is going to be 0, right? But my time, it's going to tell me when the object hits the ground. So maybe the object takes 5.2 seconds to hit the ground. When I click on that point, it tells me 5.2 and 0. It's kind of cool. It also, if I click on this point right here, it tells me what the maximum height is. It's going to be right here. Like maybe the maximum height 72. And it's going to tell me at 72 height, the time is 2.4. It gives me the values just for clicking on the graph, all right? Which is what your homework assignment is going to be. You are going to type these functions. It's going to give you a function. You're going to type it into Desmos, and then it's going to ask you questions like, what is the highest the object goes? Or when does the object hit the ground? Or it might say something weird like, how high is the object at 4 seconds? So you would have to go to 4 seconds right here, and then you would click on the graph, and you would drag your mouse until you found the point that said 4, something. So you're going to use that graph to answer questions, all right? Which is the second part of the notes that I want you to take. These three big boxes, we need to fill them in. So some of the questions are going to ask for time. So they're going to say something like, when is the ball 10 feet up? It wants to know a time value. Well, remember, time is x. So you're looking for an x value. It's going to give you a y value. It's going to give you, so it's going to give you at a given height. It's going to give you the height. It's going to say, when is the ball 10 feet up? Or when is the ball hit the ground? Which means the height is 0. It's going to give you the height, and you just have to figure out what the x value is at that height, okay? It can also ask you for the maximum. What is the highest the ball goes? All right? And again, this time we're looking for a y value. We're looking for the height, but the maximum's easy. It's just the vertex. So you're just looking for the y value at the vertex. And for Desmos, you just click on the graph, click on the vertex, and it tells you the y value. Super easy. When asked for the height, so maybe it says, how high is the ball? How high is the ball? Sorry, my handwriting is bad. I'm trying to go fast. How high is the ball at 10 seconds? So it gives you the x value that you're looking for. You are looking for the y value at that given x value, okay? So you're looking for a y value at a given x or time. So maybe let's look at one of these. So a person is launched from, oh, I love this question, the blob. A person is launched from 4 feet high off the blob at a speed of 48 feet per second. So the blob, I'm sure you've seen videos. It's a great big blob. They usually have a person like laying on the end of it. And then up here on some tower is another person. And they jump off, they land on the blob, and this person gets launched into the air. Okay, that's what a blob is. YouTube launching blobs in the water, something weird like that. You will find a lot of fun videos about the blob. So when you graph this, that person is going to go up, right? They're going to go up, gravity's going to kick in, they're going to come falling back down and hit the water. Hopefully the water. Hopefully they don't hit a person or a boat or the ground. Again, there's some sad, funny videos of bad things happening. The question is, what is the maximum height that the person goes? All right, well, let's go to Desmos. I've got a lot of functions in here, but let's make a new one. I'm going to write y equals, and again, it gave me the function. I don't even have to come up with it myself. Y equals negative 16 t squared plus 48t. I'm just copying the function it gave me, plus 4. Okay, so when I look at it, this is what the graph looks like, okay? The person, if I want to know, right, here's where the person starts, right? They start at 4 feet. Someone jumps on the blob and launches them up into the air. So they're going up, 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 up. It wanted to know the maximum. Well, that's easy. It's right there. I click on the graph and it tells me at x value 1.5, so that means at 1.5 seconds, that person on the blob reaches 40 feet up in the air. That's what those numbers mean, right? The x is the time, the y is the height. So in 1.5 seconds, that person reaches the maximum height of 40 feet. And then they start falling back down, 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 and they hit the water. Hopefully, they hit the water at 3.081 seconds. So if it wanted to know when do they hit the water, that's when they hit the water, 3.081. If it wanted to know how high were they at 2 seconds, well, I can find that out. Here's a cool thing about Desmos is if I click and just drag, it shows me my X's and Y's. So if I go to 2 seconds, that's right. Oh, I can't see what I'm doing very good. 2 seconds is right there. The person is 36 feet in the air. That's pretty high, right? So easy assignment. What you need to be doing is not these questions. These are note questions. I don't think we need to go through all of them. I want you to do this worksheet that you should have picked up in class. Go to desmos.com, go to the graphing calculator, type in the function that it gives you, draw a little picture of what's happening, and answer the questions, all right? Again, don't panic. Look at the first equation it gives you. It doesn't use -16. It uses -5. That is okay. That just means your answers aren't feet. Your answers are meters. And that's okay. We can measure things in meters. We're not very good at it because we're in the US, but we can still do math with -5. You just type in -5 instead of -16. Good job. You're good at doing meters. All right. Let me know if you have any questions.